Okay, what are we going to do today? We're going to have a video to introduce you to a Float 32 audio. What's Float 32? Well, in digital signal processing, it means that we are capturing a 32-bit wide DSP signal of the audio that's being digitized essentially. And what does that mean? It means that we've got an extremely wide dynamic range. Wide dynamic range means that we can whisper something or we can be extremely loud, and the microphone will capture all of those things. In other words, it won't clip anything, it won't essentially all the audio is captured because it's got extremely wide dynamic range. What it means is that when we process that audio, we should get a very full spectrum. In other words, if it's processed correctly, we can whisper something or we can scream something, and the microphone level will be constant. It will still capture that extremely wide range. Obviously, this is used in audio recordings and so forth, but is there any benefit for amateur radio? This is basically what I'm trying to investigate. So what I'll do an intro into Float 32. We'll see a little bit of a video and the effect. Second thing is we're going to do a demo with a Hermes Lite 2. Hermes Lite 2 is capable of receiving audio which can be generated with a microphone like that. Not all radios will be able to utilize the fact that we've got such a wide dynamic range. So with an SDR, it's possible to do that. So let's have a look to see if we can actually capture that wide dynamic range and how the audio actually sounds. So that's basically what that second part of the video will be. Anyway, that's the plan for today, and I hope you enjoyed the video.
32-bit floating point audio means that every sample of your audio, every instant that's captured in your audio file, has 32 zeros and ones that make up that value. 24 and 16-bit have 24 bits and 16 bits respectively. But the big difference is not just that with 24 bits, you've got 16 extra bits, so you can make even more numbers than a 16-bit file. But with a 32-bit float file, not only do you get an extra 8 bits, but it's how those 8 bits are formatted that makes a huge difference, because it becomes an exponent. Instead of a linear number, it's a floating point integer. And so you have a number that's still 24 bits taken to an exponent, which is 7 bits, and you have an extra bit for a positive or negative. So you end up with this huge range of numbers. And to compare, a 16-bit file can do, I think, 65,000 different values, which translates to about 96 decibels of dynamic range. 24-bit linear can do, I think, like 16 million, which I think translates to around like 144 decibels of dynamic range. 32-bit floating point audio can do, it's like a 5 undecillion. It's 5 with like 38 zeros after it. That's how many different numbers can exist in a 32-bit floating point audio file. And with that, you end up with, I think, 1,500 decibels of dynamic range. It's an unbelievable amount of audio range. And when you consider that from silence to the loudest sound ever recorded is less than 300 decibels, you can fit pretty much anything inside a 32-bit floating point audio file. So what does that actually do for you? It lets you adjust the volume and the gain afterwards. So when you record a 32-bit floating point audio file, the first thing you do historically is set up your microphone and then adjust your gain.
Looks like we've hit the nail on the head straight away.
We are unable to process Float 32 in real time. It is recorded internally to the 8 gigabytes of storage into the microphone. So as far as using it with external devices, in particularly via Bluetooth, no way possible to do 32-bit float. My gut feeling is that it's processing at 24 bits and probably at 48 kilohertz. So it's nevertheless a good microphone, but for Float 32 applications and the wide dynamic range, it's only post-processing. In other words, we record effectively in RAW, so to speak, and then we take this information into a processing bit of software where we can edit and we can expand, compress, whatever we need to do with the audio, because it's all captured there. So keep that in mind for the further aspects of testing in throughout this video.
Okay, let's have a look at this Float 32 microphone. Basically, it's it's made by DJI. They're the drone people. If the people that may not be familiar with them, they're the leading drone manufacturer. But they also do podcasting hardware, and one of the things they do is the microphones, and also recording cameras like a Pocket Osmo Pocket 3, which I think some people who are watching this already are aware of it. Anyway, this is a close-up view of this microphone. This is a Mic 2. It's quite interesting. It's got a translucent sort of case, so you can actually see some of the electronics in there. And needless to say, it's not a trivial little device. It's a pretty complex DSP gizmo that can record audio on its own with no additional hardware, and it records it in Float 32. I keep on saying this, but that is a very significant thing if you really understand what it means. So let's have a look at this microphone a little bit closer. Nothing special.
What I should have said is nothing special looking, but it is an incredibly special microphone. It can record Float 32 internally for 11 hours and 24 bits for 14 hours. So the battery definitely lasts at least 14 hours.
It is just an ordinary microphone, but it's Bluetooth. It's also got a capability where you can actually plug in a lavalier external microphone capsule, essentially no processing or anything, just literally a microphone in there, and this will actually use that. But it has its own internal microphone. So the internal microphone is pretty good. It obviously has battery. It can be recharged on a plug-in stand. It also has a USB device that you can interface to.
Primarily to pull off all the recorded data from the internal storage.
Mainly for charging the internal battery. The internal battery lasts something like 4 hours.
Add 10 to that, it's actually 14 hours.
And it has a little magnetic clip. The back of it is magnetized. I put some tape on there because every time the clip goes there, it really bangs it and scrapes it. So basically it just gives you a little bit of extra, not protection so much, but it easier to remove the magnet, put it this way. So you basically put that behind your clothes or something, jumper, whatever, a shirt, and it sort of clips it, unless you've got something specific that you want to clip it to. So that's the microphone. They're not that expensive. When I say not expensive, they're over about $150, but that's for this type of microphone. If you look up Float 32 mics, you're not going to get anything for that sort of price. So what we're going to do is see, can we adapt this microphone for use for amateur radio? So that's the sort of mission for today's video. Okay, some time back I did a video on the Hermes Light, and I'm not sure if people watching this one are aware of that, so I thought I'd just revisit that and just show you what the hardware is that we're doing the testing on. This is my setup for the Hermes Light. Essentially, power going into the Hermes, 12 volts at a 2 amp capability, Ethernet connected to the local network. The Hermes light has got a little amplifier sitting on top of it. It's MX P50M. Technically it's supposed to be 50 watts, but the useful power is about 35 watts. And on top of that, I've got a little SWR power meter. Essentially, this allows me to sort of monitor the SWR and power coming out of the Hermes. The Thetis software does that anyway, but it's always good to have some sort of a hardware device monitoring it, and you can cross-reference the two. The back of it is quite straightforward. The RF coming out of the Hermes goes to the amplifier in my case, and then from the amplifier it goes to a sampler, an RF sampler. Now the RF sampler, what does it do? As the word says, it samples the RF. RF essentially goes through this device, and this device is capable of handling, I think, about 1.5 kW. So once the RF goes through this, it produces, or the RF is tapped at approximately minus 50 dBm. So we've got a sample of that RF going out of this little cable and going into the Hermes. The Hermes has circuitry where it'll detect that and it'll process that sampled RF, pre-distort the output from the Hermes, so the sampled RF, which includes any non-linearities from the amplifier, will be compensated. In other words, we're pre-distorting something that is not right to make it right. So we're sort of adding a pre-distorted input to the output, so when it goes through the amplifier, it will modify the output with the pre-distortion, so the output will be more linear, or, you know, as we expected. Sounds complicated, but it's pretty simple in a way. The sort of theory behind it is simple, but how it works, it probably is quite complicated. Anyway, it does work, and that's what the whole pure signal stuff is. So you'll probably see that in the demo that I'm going to do anyway. So that's the setup for the hardware. Now we're going to be testing that with the Float 32 microphone. Essentially, the Hermes and the Thetis software is capable of dealing with the Float 32 audio signal, and we'll see how good that audio is in terms of the capability of the wide dynamic range. Now, to test that, I'm going to be doing that off air. So to do that, I'm going to be using a little SDR. This is a little device that I got years ago. I think probably more than 5 years ago. I don't know if I still make it, but this is sort of like a clone of the SDR Play. The lowest, I think it's the SDR Uno or something, the lowest version of the SDR Play range of hardware. I don't know if SDR Play was happy with them producing this, and there was a bit of controversy at the time. So I think they're making it clear that they're not really labeling it or saying that it's got anything to do with SDR Play. But that is a clone actually, and it works with all of their software. I don't know if they still make that. It may still be available, but it just works, and it's quite good. It works from 10 kilohertz to 2 gigahertz. And I think at the time I paid something like $50 or $60 for it. So there we go. So that's going to be hooked up, so we can actually monitor the output out of the Hermes. All right, so let's get on with it and take it to the next level. Oh, by the way, I did not show you the output out of the Hermes is actually going into a dummy load. This dummy load can handle 200 watts. And it's pretty good. It's very linear. It goes up to 3 gigs, and yeah, I put it on a VNA, and it is pretty flat up to 3 gigs, so that's pretty good, and 200 watts. So yeah, I thought that it's best to run it through a dummy load rather than you know, just even low power, low transmission, because I'm just doing all sorts of mucking around with the Hermes and I don't want to blow it up. So that's basically the dummy load that sits below the Hermes. I've actually got this, you know, it's sitting in its original packaging, and the Hermes box sits on top of it. So I'll just show you guys if you want to have a quick look. That sits on top like that. Okay, so there we go. Yeah. So I hope that makes sense how this setup is done. So we've got my little SDR Play clone is going to be sitting next to it, and it's going to be receiving the signal that the Thetis and Hermes will be producing. Okay. Welcome to my computer screen. Okay, so this is my laptop desktop, and we're going to fire up Thetis. This is the latest version of Thetis, as a matter of fact. It's been released, I think, on the 11th of May. Yeah, on the 11th of May. So, look, I've got a specific skin that I set up for Thetis. Now, what I'm going to do, I'm going to move Thetis into another window. So, let's just go into that window. There we go. And let's make it full screen. Now, I'm not going to go into the Thetis, how it works and all that. That's for another video if you guys are interested. But that's my particular skin that I chose, and that's the actual system set up. Now, I've got a dummy frequency that I picked, 7150, and at the moment, just to demonstrate the system, I'm going to do a two-tone test. And first of all, I've got to switch it on. If I power it up, it comes up. Obviously, it's connected to a dummy load, so you're not going to see any signals. That's just basically noise that it's picking up. I can adjust the level here above or below, so I'm just going to put it just on the threshold there, so you can just see a little bit of activity there. My profile at the moment, I've got it set to 7K. I know that there's some people that are interested in extended sideband, and I think legally we're allowed to use up to 8 kilohertz. That's pretty wide. So this profile at the moment is set for 7K. I thought that's appropriate, just to test the microphone on it, just to see how it actually modulates right across. So I'm going to switch. I'm going to move that across. So essentially, we're lower sideband, so we will see our signal going out this way here. Okay. So right now, let's just test to see if we're getting a two-tone, and we are. You can see pure signals enabled. That means we're doing the pre-distortion, and everything seems to be running okay. So let's just turn that off. Now, what I'm going to do, I'm going to turn that microphone on and make sure that it is connected to my laptop. Right, it's connected now. Mate, it didn't take that long. So let's get back to Thetis and make sure our mic input is working. Right, so now with Thetis, we got microphone. If we go to setup, we can have a look at the mic settings. Let's just switch the screens. We can see that the DSP, or I should say audio, we've got the input, we want that, which is the DJI Mic 2, and everything else is okay. So we will apply that and get out of it. And now we can go back to Fetus, and technically we should be getting that microphone input audio. So let's just have a quick power up and see what happens. Oh, here we go, 7K wide, and we've got pretty high level on the mic. Let's just drop this a little bit because it's really peaking. Here we go. Right, as you can see, as I'm talking, it's modulating. And I'm going to talk really loud. 1, 2, 3, 4, 5. You can probably hear that the audio is modulating on the recording here, but Thetis is just staying steady because the Float 32 is working quite well.
Unfortunately, I hate to say it, but the Float 32 has nothing to do with the fact that we're getting reasonably good audio. It's always like this. When you actually do a physical test and experiment, you just realize all the aspects that may have not come into play. Float 32 is definitely being recorded by the microphone, but it is not going through to the Bluetooth and back into the PC and back into Fetus. Think of it like a JPEG and raw image. The raw image is captured by your camera, in our case the microphone, the Float 32. It's physically recorded with all the appropriate circuitry on the microphone itself. We can recover that raw file, i.e. the Float 32 file of the audio, and then we can process it. We can process it using some audio recording and editing software, etc. And we can look at the waveforms and we can enjoy the 32 bits. But as we're transmitting it via Bluetooth to a receiver, i.e. the laptop, and then looking at it, we're not getting Float 32. We're getting a high quality audio stream, but not Float 32. So in short, this little experiment has just proven that we're not going to get Float 32 out of this DJI microphone, or probably any other Float 32 microphone. We can process this audio, get Float 32 results, and then I suppose not have a real-time QSO. So that proves the fact. But nevertheless, let's carry on with this video, and we can see how good this microphone is without the Float 32 function.
And I can whisper as well. As I'm whispering, it is still modulating. It is still modulating as I'm whispering. Even very quietly like this, it is still modulating quite well. And if I go loud, it is not getting much beyond what it's supposed to be getting. So the Float 32 works pretty well. We can't hear it at the moment. We will hook up the receiver and we will listen to it later on. But at the moment, it seems to be working okay. So let's just kill that for now and have a look at the system later on. Now, let's just see if my pure signal is still working. Yeah. What do we got? The drive. We've got very low drive, actually, as a matter of fact. I didn't realize that. Let's just put it back up. Let's try this now. 1, 2, 1, 2, 3, 4, 5. How does that sound? That sounds all right. 1, 2, 1, 2, 3, 4, 5. You can see that it's flat topping. In other words, I'm getting audio right through the whole 7K. It's not concentrating any frequencies at one end or the other end. It is flat topping. So it's spreading my audio right across. And I have not done anything to it. I just literally plugged in the Float 32 mic. That seems to be looking good on the spectrum, but we'll have to see how it sounds in real life. And not getting enough power to enable the pure signal. What's going on here? It's the mic drive, probably it's not enough. Let's have a look. And if we go now, yeah, you're getting a little bit extra drive. There we go, pure signal is now working. You can see the range, it is very, very solid. That's because of the gain on the mic. I need to drop my level a little bit because I'm actually going way above what we're watching. Here we go, that's a little bit better.
What I should have done is activated the de-expander, which I will do later as I realize this, but I didn't say anything. Essentially, de-expander will kill any noise unless you're talking. It's sort of like a reverse Vox. You'll see that. So apologies for that.
1, 2, hello, hello. Okay, let's just move that up a bit. 1, 2, hello. Still too noisy. Yeah, let's have a look. 1, 2, 1, 2, 1, 2, hello. 1, 2, 1, 2, 1, 2, hello. Okay. Right, so that's probably a good setting for now. So let's leave this for a sec, and we will now go back and fire up our SDR play so we can monitor this. Let's have a look back to our screen and SDR Uno. Switch it on. Now, I can't monitor that because the audio is going to my Go stream, the OC Go stream, so it's not going to, well, put it this way, I can't hear it, but I will be able to see it. So let's fire up. Let's fire up Thetis again, turn it on, and here we go. And let's have a look. Are we getting out? Yeah, before we do that, let's just do a two-tone test, and we can see if it's coming up on the spectrum. There it goes. We can actually see it on the spectrum. There's a two-tone test. So whilst we've got the two-tone test, let's zoom in on this, and so we can see it better. Okay, that seems to be okay. And let's just shift this across. Now, let's kill the two-tone and go back and just ramble on and see what happens when we talk. Hello, hello, 1, 2, 1, 2, 3, 4, 5. Well, it's modulating, but it's very weak, as you can see. My antenna is not really that close to the output. Let's put it closer, because we're going into a dummy load. There we go, that's a little bit better. Maybe I can make it even better. How can I do this? I'm doing this off camera, but I'm just going to put the antenna right into the dummy load. I think that should be better. Yeah, hello. Alright, that looks as if it's getting the signal at least into the SDR play. There we go. 1, 2, 1, 2, 1, 2, 1, 2, 3, 4, 5. I really don't know how I sound. I should be monitoring myself somehow. So it could be crap, it could be good.
Oh dear, when you're doing live recordings, it's really difficult to control everything and make sure you get it right. I just thought I'd just add this comment. As I'm monitoring here, I'm actually monitoring 2K wide audio, even though it's transmitting at 7. Then I actually expand that further, and the maximum that SDR Play will do is 5K, so you'll probably see that. I think it's 6K, and you probably see that, and it's not the full 7K, but nevertheless it sounds pretty good. So I just thought I'd just add that for those of you that noticed my little errors.
It's as wide as the SDR Play will go, actually. Anyway, this is just a demonstration. As you can see, the spectrum is still being modulated right across the 7K. And if we look at the Hermes, we're really killing it here. It's quite narrow and right across the spectrum. A little bit of modulation. Hello, 1 2 1 2 3 4 5. Seems to be going okay. I'm not sure how it sounds. We will see later on. Pure signal is still working, so there we go. We've got 7K audio. For those of you that are interested, it's perfectly legal and extended sideband with a Hermes. Relatively easy to set up, and if anybody ever gets a Hermes and wants to play around with us and need some help, I'm very happy to help them out. So that's an open invitation. So let's just go back and change our audio to something more usable that most of us will be using. So let's kill the output for now. We'll disable that and pick a profile that I've set up before. Say something like 3K, 4K. And put that back on. So now we've got a different profile. 1 2, hello. Let's put it back in the center. Hello, 1 2 2 1 2 1 2. I'm not sure if that's the best profile. I can't remember. I've set all these up ages ago when I was actively using this, but now I'm not. So there, yeah, that's probably slightly better. Okay, so as you can see, pure signal is running, and we're modulating, and that's our level using the Float 32 microphone.
Please note, as stated previously, we are not processing Float 32 bits.
When we're talking, that's the level that we're getting. Pretty flat, obviously a little bit higher on the lower band or frequencies. Well, that was a deliberate cough just to try to peak this audio. And on the recording, it probably sounds really loud, but thetas on our SDR Play should be good. Let's have a look at this. 1 2 1 2 3 4 5. 1 2 1 2 3 4 5. More levels here at the lower end, at least on the receiver. Let's change our band to say 4K. 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know why everybody says 1, 2, 1, 2, 3, 4, 5. We could just be talking and testing the microphone. It's a silly habit, and I'm trying to break it. So I'm just talking now, testing the audio levels, and see how I sound on the SDR Play pickup here. As you can see, there's higher modulations or more energy going in the lower frequencies. That probably is expected because that's where my voice energy is probably concentrating. So let's call it a quits. I hope that was a good demonstration. We'll play back the audio and have a look how it sounds. Or at least I will play it back. You guys probably heard it already. Until next time. I hope that was useful and definitely worth investigating the Float 32 microphones.
Just to reiterate again, we discovered that Float 32 cannot be used with HF radios in real time. Remember that.
I think they're very beneficial with a little bit of tweaking. You can have a great audio on your rigs with this particular microphone.
That is very true. This microphone is extremely good and can be used for Thetis or any other HF radios. Very, very good response.
And you just stick it on your lapel and it's not near your mouth or anything, and it works extremely well. Well, that was my little effort of Fred Flintstone. And Fred has a friend at the extreme. Anyway, this may not be perfect, but that is supposed to be George Jetson. Now, one of them is, I'm looking at this is really crazy. I used to be able to do this properly, but I totally am out of it. George is the future, and Fred is the past. I guess there's maybe two schools of thought in the amateur radio group. There's the guys that like the past, and there's the guys that like the future. And maybe we all fit somewhere in the middle. Anyway, that's a little bit of a distraction. I hope you enjoyed the little scribbles there.